morning, students. Today we will discuss over the topic of application of remote sensing and GIS techniques in soil resource management. As we know, soil is an important resource which is used to mechanical support to the soils and uptake to the plants. So here we are interested to know how to use remote sensing and GIS techniques to address the problem which is related to soil resources, and what are the applications we can address, where we can, how can we use this technology to manage the soil resource. So in this concern, we will able to understand how to remote sensing and GIS application can be used as a tools. As we know, remote sensing, this is a space-based technology which is used to understand the application of satellite images, visual interpretation of the satellite images, and by using geospatial software and computer system we can map these soil resources. So before starting this topic, we would like to understand what are the differences between remote sensing and GIS. Remote sensing, it provides an opportunity to capture the synoptic view of the earth surface or area of interest, where GIS is used to convert into information system whatever information or images have been captured and processed through computer hardware and software. GIS means geographical information system. Basically, geographical information system, there are three mechanisms. First one, geographical area. Second one, information, how to convert into information system. Or S means to the peoples, to the people, and how to these technologies like remote sensing, GIS, geoinformatics, geospatial technology, whatever we can say, are today at the present scenario, these techniques are being used to address the natural resources as well as to solve how to use this technology to solve the problems related to soil, water and vegetation resources. Here, the main objective of this class, how to use this techniques, this technique in the field of agriculture system. So this for this concern, we focus on, there are three objectives we have selected to describe here. First one, to aware about how to use remote sensing and GIS in the field of soil health management, and what are the methodologies should be adopted for the mapping process or digital image processing or conversion into information system by using for digital mapping and decision support system. Second one, what are the applications involved under remote sensing and GIS techniques, so that we can characterize the natural resources and whatever geospatial features are on the earth surface we can trace out. Third one, there are some cases have been tried to portray here, so that can be demonstrate before you how does this technology help to understand how the space technology in terms of images and signals may be helpful for the management of soil resources. These are the main objectives what we have to discuss today. Why space technology or remote sensing, GIS or telecommunication? Because the most important thing is acquiring information about the earth's surface. without actually being in contact with. Means remote sensing, what does it represent? Remote sensing? Remote sensing acquiring information about the earth surface without actually being in contact with it. It means satellite images or remote sensing technique helps to identify or capture the synoptic view of the features whatever available on the earth surface, which is without actual touch. Second one, this is done by sensing or recording based on reflected or emitted energy of the target or area of interest or those geospatial features. Reflected energy or emitted energy, both are different from each other. Reflected means reflection properties. Emission means emission of the target. Reflected or emitted energy is converted into image by using some algorithms or devices which is inbuilt in satellite sensors. Okay. Where the most important thing is we have to understand what is the role of digital image processing, because this is the fundamental thing, how to image process by the computer system and software. Why we are interested to know digital image processing? Digital image processing helps to capture the geospatial features by using satellite images based on tone, texture, shape, size, association, shadow. These are the visual interpretation keys as well as some rhythms have been applied to process the image or images. Third one, reflected or emitted energy is converted to image. We can do. Remote sensing is different from GIS and GPS. We have to clear cut understand, because remote sensing is different from GIS and GPS. Remote sensing means simply we have to acquire digital images from satellite sensors, where GIS helps to process the images by using digital image processing in terms of whatever geospatial features are available on the earth surface, that can be processed through computer hardware and softwares. So here the another term is associated like GPS. GPS means global positioning system. We have to understand about global positioning system means where we are standing or sitting here. So what is the actual position on the ground? We can address in terms of coordinates, latitude or longitude, even what is the elevation from mean sea level. That can be addressed through global positioning system. Okay. So these are the technical terms which are associated under remote sensing as GIS techniques that have been we have covered. Now the next step is the main objective of remote sensing is first one, to provide synoptic view in terms of earth surface, lunar surface, or we can say for area of interest where we are interested to work on. Second one, images are available in soft copy. Here we have written soft copy. We have used the term soft copy, means there is not in hard copy or not in page. It is available in soft copy, means digital data. In terms of GeoTIFF file arrangement of pixels and their digital numbers. which comprises in digital images. Dependent on a skill towards processing of the imageries and signals and conversion into information system. This is basically, it is considered under a skill, how to convert into information system when we use this technology, or when we will be able to know this technology. So without digital image processing, without computer hardware and geospatial softwares, that cannot be processed, images cannot be processed to convert into information which is directly linked with geospatial features which have been traced out based on interpretation or mapping. We can, ultimate product is mapping. It is done by geospatial software, we have already discussed. Remote sensing acts as a data provider and supports to fulfill the objectives to the GIS. Okay. Here this is an image portrait on the blackboard. We have to understand what is image and a spectra. Image is directly interlinked with reflected energy in terms of wavelength, interval or reflectant properties of in different wavelength or interval, wavelength interval. So images is the byproduct of reflected energy or emitted energy of the target. Here there are three type of features have been portrayed. First one soil, second one water, third one vegetation. Accordingly, we can see here, this is the spectral responses for water. What is this? Is the spectral reflectance curve for vegetation, and this one for soil. But we can use here in the field of a spectroscopy, but in same manner when we use remote sensing, it is described under images, whatever captured by the satellite sensors. So there are differences between image versus a spectra. Spectra means this is a technique to understand what are the spectral properties of the target. Our image, it provides an synoptic view of the target by the reflected or emitted energy. Is it clear or not? Now the question is, which type of satellite data can be used for soil resources management? What are the satellite data are available? We have to understand. There are several data in terms of multispectral images or data, in terms of hyperspectral, in terms of thermal, even in terms of microwave data are available to interpret the geospatial features or to interpret the soil resources. When we are interested to cover the soil survey or soil surveyed area, then we can use this data in terms of multispectral, in terms of hyperspectral, thermal or microwave. Okay, that's why we have written here types of satellite images. Like multispectral image, there is limited bands 1, 2, 3, 5 or 7, 8 or 9, 10 something, but hyperspectral images consist more than 100 bands, 200 bands in narrow way. Okay, but in terms of thermal image, it represents based on emissivity of the target, and microwave, artificial light, radar we have discussed, radar, radio detection and ranging. By using microwave data, we can interpret altitudinal variation or height of the crop, field crop or object. Here the term has been used panchromatic image. What does it mean? Panchromatic represents single band like black and white image which is available under the wavelength interval of infrared. What I mean? Means panchromatic image represents single band valued image which is available in the band interval of infrared. Okay, suppose we say multispectral image, there is blue, green, red, infrared, short wave, near infrared, short wave infrared, even thermal infrared. Okay, but when we say panchromatic image, it means it represents only infrared band. Okay, here we have, it has been written true color composite image. Okay, whatever we see, the area of an area of interest or object or natural phenomena with our eyes, it represents true color. Okay, when we use satellite image in terms of infrared, this is additional band, no? That can not be seen with our eyes. Okay, but when we use panchromatic data or multispectral data, satellite images, that can be considered under false color composite. Our eyes represents as true color composite because there is three color, blue, green and red only. But in terms of multispectral images which are provided by satellite sensors, it includes infrared also. Digital image, digital elevation model or elevation data which is provided by radar data. Okay, suppose Carto DM, SRTM data, basically this data available under microwave, radar, SAR. Okay, so we use the data for the purpose of altitudinal variation, identification of altitudinal variation or 3D mapping. Okay, some important facts like orbit, geostationary, sun synchronous and swath. Geostationary or sun synchronous, we satellite images consist digital values of the pixels which are captured under sun synchronous process. Okay, here electromagnetic radiation, electromagnetic spectrum or wavelength interval, bands, spectral signature, data interpretation, resolution, pixel size and scale, These terms are associated in digital image processing, है ना? So further we will able to understand what, है ना, actually it is considered. Here there are two images have been portrayed. First one, true color composite. Second one, false color composite image. True color composite, whatever we see with our eyes, but in same image, when we use near infrared, this true color composite may be converted into false color composite image in terms of layer stacking bands of green, red and near infrared. Okay. Here we can say what does it represent? It represents vegetation, water bodies, sand patch in white tone. In same manner vegetation appears as red. When we incorporate near infrared, it means there is much reflectance of infrared band in our infrared band comparison to green band. That's why we see here, no? Now the question is, which type of software is being used to process the satellite images? First one, ADAS Imagine. These are the commercial software like ADAS Imagine, GIS. Okay. Even TNT Maps, NV, but in terms of GRASS and QGIS, basically both are open source software, free we can say. In same manner, what are the uses, applications of softwares? First one, how can we use softwares? In terms of digital image processing, we need. Second one, digitization. Third one, digital map preparation. Finally, it provides an ultimate product which is known as decision support system. When we compile all the information by using software and computer hardware, finally we will be able to understand what are the actual position is there. Position means what is actual applications we can apply. This is the glimpses of some sorts of information have been gathered during lab activities. Here we can say this is the main track of river Ganges. Okay. But the most important thing is what is the actual situation of river Ganga in 1990. In same manner, what is the actual situation of in 2006 of the river Ganges, and in 2020 what is the actual situation? What does it mean? It means it represents the synoptic view of the river Ganges, whatever we have gathered from satellite images and has been converted into information system by using computer hardware and software. Then we can say there is trend how the river Ganges shifted from year to year, year-wise shifting. What is the decadal change in river Ganges? So we can understand even what is the actual cropping sequence in adjoining of river Ganges. Can we understand? No? That's why we use this technology. Here, this is the image of or interpreted image of whole Vihar, and this is the actual view of the river Ganges. This is an image of a wife's data, which is covered in 15th May 2015 band 543. 543 means, what does it mean? Short wave, near infrared or red. This is, there is variation between greenness and magenta tone. So when we able to understand what are the possibilities we can address this magenta tone when we go through visual interpretation of the satellite images, we can understand or we can guess this is the property of clay nature soil. What does it mean? Clay nature soils, because there is barren land, fallow land we can say. So, reflectance of the clay nature soils that can be traced or that can be addressed. This is not appropriate, but we can visually interpret it at a glance. So, in some images we use, this is an image of Patna district where we can say where is clay soils like tar land in Mokama tile. So by using satellite image we have extracted clay soils of the Mokama district, where it represents the Mokama tile area. This is the actual situation of Mokama tile in bluish tone. This is the synoptic view of the satellite image. By using that satellite image, we can trace out. Application of space technology in flood management, we can say. Inventorying of flood affected area, digital surveying and mapping in terms of soil resources, water resources, even cropping pattern. Soil moisture, this is important thing that can be traced or addressed through satellite applications, satellite images. Detection of problematic zone, what does it mean? By using remote sensing and GIS techniques, we can judge what is the problematic area where land use planning should be applied, what is the contingent plan may be promoted in affected area. In that situation we can apply this technology. What is the vulnerable zone or vulnerable area where we can promote the prevent or safety measures technology or even mitigation options. In this situation we have used site suitability. This is most important thing we have to understand as a soil scientist or soil researcher. Land suitability, site suitability based on soil resources, management of soil resources, diagnosis of different soil parameters. We can extract land suitability class by using this technology to address the actual crop or a screening of the actual crop. May be possible. Soil information system, change detection, interpretation of a specific soil characteristics, like a specific soil characteristics. What does it mean? A special soil characteristics like tar land, Diara land, oxbow nature, bog soil, wetland soil, that can be traced out by using this technology like remote sensing. Interpretation of a specific, which has been covered, a spectral database. When we go through clay mineralogy, analysis of clay mineralogy, in that case we use a spectral properties of the target. A spectral property is nothing else, it is advancement in a spectroscopy so that we can trace out the actual value of the mineral of the particular soils. Suppose we zinc deficiency, iron deficiency, potassium, nitrogen. So how does it possible? How can we diagnose? In that situation we use the term a spectroscopy, a spectral properties. Last one, geospatial modeling. Modeling means when we considered over the matter of decision support system, we go through geospatial modeling like artificial intelligence, machine learning, deep learning, things of internet. These approaches have been covered under modeling. Yes. These are the glimpses of work, whatever we have done during lab exercises. Yeah, this image represents Katoria block, where in cyan color or light blues it represents fallow land. This image represents digital elevation model. It means what is the actual or what is elevation and geological structure which has been addressed through a spectroscopy as well as interpretation of satellite images. And red soil patches, this one, and what does it mean? No, this image represents drainage pattern, watershed. Okay, so that by using remote sensing and GIS techniques we can delineate watersheds to manage these soils as well as water resource. नहीं कर सकते हैं. In same manner we can calculate how much area under catchment, particular catchment, how many catchments are there, we can interpret it by using this technology. So that we are interested to demonstrate. Yeah, this is the image of Tal and Diara land. Here you can guess under agroclimatic zone in this one current Diara land. Okay, and in same manner this is Tal. Okay, when we interpreted the satellite image, we can find out the properties of clay soils in this manner or this tone. Okay, this is arbitrary tone which has been assigned or interpreted through satellite image and converted into information what we are interested to gather. So in same manner we can find out the spectral value in terms of elemental status like aluminum, Ag silver, Au gold, copper. Most important thing is this is the wavelength interval. So what is the actual peak in which position in terms of particular wavelength? In same manner we can address By using satellite image, because satellite image is also the product of spectral properties of the target. Is it clear or not?
Yes, sir.
Hmm?